A student is skateboarding up a 30-degree ramp that is 1 meter high. When he leaves the ramp, his speed is 7 meters per second. So question 1. How far from the end of the ramp does the student land? Second question. What is the impact of velocity? So we show you a diagram here. This is a guy, 1 meter high, 30 degree. So this will be question 1. How far will it be? Second question. What's the impact velocity? So now we show you an equation. Back to the diagram, we are looking at the x and the y. So the x component, we are using this formula, we are getting the degree, 30 degree, and we will get the speed. For y component, this area, we will find the speed and this gravitational force. So we start here. So y final will be 0 because it's land at 0, and we start from 1. Velocity is the gravitational force, so it will be negative 9.8 t squared. So what you will get? So in the end you get an answer. Okay, but this part, time we cannot have negative, so we cut this off, and then we'll get this one.
So since we have found time, now we are looking for x, distance. So x is equals to x initial plus velocity times time plus 1 over 2 ax t square. However, there is no acceleration, so a is equal to 0. So what's left is this. So x final is equal to 0 plus 6.06 bracket 0.933. In the end, you'll get 5.65 meter. So rounding it off, x final is equal to 5.7 meter.
So for part B, we are supposed to find the boy's velocity. The boy on the skateboard, we're supposed to find his velocity right before he touches the ground. So basically his final velocity. So in order to do that, we have to find first the final velocity of the x component and also the final velocity of the y component. So just now when we were finding the when we were breaking down the different components into x and y, we found that the acceleration for the x component is 0. So that means that Vf of x is actually equals to Vi of x. We can take the Vi of x's value, which was 6.06 meters per second. Okay, and for Vf of y, we can use one of the kinematics formulas, which is Viy plus At. So basically, if, in simple form, this is basically V equals to U plus At. V is the final velocity, U is the initial velocity, right? So we input those values and we get 3.5 plus negative 9.8 times 0.933. Okay, so from there we input the values into our calculator and we find that the velocity, final velocity of y is actually negative 5.64 meters per second. Alright, so here you can see that you already have V of x, V of y. Now you just need to treat this like a triangle, okay? And then you use your Pythagoras theorem in order to find Vf. So Vf is equals to 6.06 squared plus negative 5.64 squared, and you take the square root of that, and finally you will get 8.3 meters per second. And then in order to find this angle here, velocity means we have to find both the magnitude and direction. So in order to find this, we just use our tuakaso, and we'll find that using tangent inverse of negative 5.64 over 8.3 will give us negative 43 degrees. So yeah, basically there you have it. You found your final velocity, and you've also found your angle, your direction at which the boy is traveling, the skateboard is traveling.